In this session, we will learn how to compile and link external libraries in Scilab. We will explore how to link external libraries, configure compilers to compile and build C program libraries in Scilab. In Scilab, we have a dynamic link module, which provides various functions to manage external libraries. In Windows, external libraries are dynamic link library files with .dll extension. Using this dynamic link module, we can load and unload DLL files into Scilab. It has various functions to compile the external C functions developed using the API module for use in Scilab. Here, we have functions to link and unlink external library files in Scilab. First, by using the DLL-info function, we can check the symbols which are available in the DLL. Using the C-link function, we can check if the library is loaded. If not, we load it using the link function or unload it using the ulink function. It is not recommended to call the link function directly. Instead, we need to call addInter function, which will load the library and set the entry point to the required function. Now, we will see how to load the library file into Scilab. In the last session, we developed the code for our matrix multiplication function and used it from the libmvp library. Now, we will look at the loader file and understand how to load our library in Scilab. First, it checks for the type of operating system, then gets the file path of the loader script. Then, using the C-link function, it checks if the library is already loaded or not. It will unload the previous library if it is loaded. Then, we have list of the functions which we need to load from the library. Using the addInter function, we specify the library file and the function list to load into Scilab. Once loaded, all temporary variables are removed. Let's run this script and load our MVP function. Now, our library is loaded. Let's verify it using the C-link function. Since our library is loaded, C-link function returns true and we get the ID of the library. To unload this library, we call the ulink function with the ID of the library. Then if we call the C-link function, it returns false because the library is unloaded. Here, we have functions which compile our external C program files into a library file. To compile the C function, we use the ilib-build function. The compiling process is completely automated and we need not call any other function. But, if we are using any external program development environment, like Visual Studio or code blocks, we need to use these functions to create loader and cleaner files, using genLoader and genCleaner function. GenLoader function will generate the loader file which we just saw earlier. Before compiling, we can also check if the required compilers are installed, using findmsvc compiler, and have a compiler function. Before compiling, Scilab performs internal checks to ensure that required compiler is installed in our system. Scilab supports variety of compilers both for 32 and 64-bit Windows. Now, we discuss the main function, which is used to compile the code within Scilab. ilib-build function compiles our code into a dynamic link library, which is then loaded into Scilab using addInter function. ilib-build function accepts many input arguments, which controls the compiling process. In the table argument, we provide the Scilab names for the functions, and their corresponding interface names. In the files argument, we provide all the code file names that are to be compiled. Libs argument provides names of external library files to link during compilation of our library. Now, we compile our MVP function C file code to generate our library file in Scilab. Now, in the console, we write the ilib-build function and specify all the arguments required by the function. After compiling, additional files are created in the working directory along with our library file. We need only the library file and the loader file, Other files can be deleted. Please note that we need to load the MVP library every time we start up Scilab, using the loader script, and then use the MVP function. That brings us to the end of this session. Thank you for your interest and attention.